Hello and welcome back to Introduction to Astronomy. So in our previous segment we found that the force of gravity is equal to a constant, which you don't need to worry about, and then multiplied by the mass of object 1 times object 2 and then divided by r squared. And I want you to notice it's got a minus sign in front, and so what that means is that gravity always pulls in. Now, when we start talking about electricity, we're going to find out that there's two different kinds of electricity, positive and negative. And so if you've got a positive charge and a negative charge, they are going to attract. But if you have a positive charge and a positive, they're going to repel, and a negative has repelled. So you probably noticed this when you've worked with magnets, that a north pole and a north pole repel, and a north and a south are going to attract each other. So gravity is different. So gravity always attracts. Another feature that I wanted you to know is that every object in the universe is pulling on every other object in the universe using this formula. So you are being pulled on by the gravity of Mars. Your mass would be mass number 1, and then the mass of Mars would be like mass number 2, and then there's a certain distance between you and Mars, so you're actually feeling the gravitational force of Mars. You're feeling the gravitational force of stars that are millions of miles away. But since they are millions of miles away, that means that r is very big, which means the force is very small. Okay, now we want to apply gravity to the tides. So first of all, what are the tides? So you may have noticed them whenever you've been by the ocean, and you notice at a certain time of day that the water gets deeper so that the tides are coming in and then the tides go out. So what's causing that? Well, if you've ever noticed, normally the moon is out when this happens. So it's going to be the gravity of the moon pulling on the oceans of the earth. That's going to pull up the water, and then that is going to be the tides. So if we were to draw a picture of what's going on here, so let's pretend that there's the earth, and now let's assume that there's no other objects nearby, so that the oceans would form a nice uniform layer around the earth. Okay, now let's include the effects of the moon. So let's put the moon over here, and then the gravity of the moon pulling on the water is going to cause that water to bulge. Now this is greatly exaggerated, towards the moon, and I think everybody could understand that. But you also have a high tide on the opposite side of the earth. So when this high tide is happening, you also have a high tide on the opposite side of the earth. So that means that whenever you see a high tide, in general, 12 hours later, you're going to have another high tide. And so we want to understand, why would the water bulge on this side and this side over here? Because this kind of makes it seem like gravity is pushing the water away. But we just said that gravity always attracts. Okay, so the answer to this, in simplest terms, is it has to do with the distance. So the distance from the moon to this water over here, the distance from the moon to the earth itself, and then the distance from the moon over to here where you've got the other water. And so we learned last time that if the distance gets large, okay, the r gets large in this formula, then the force of gravity gets weaker. So which of these three would feel the most amount of force if it was just up to the distance? It would be this water over here. So this water would be attracted the most towards the moon. Okay, now the earth would be attracted to the moon, but not as much. So it's going to move towards the moon, but not as much. Okay, and then this water over here comes in last. So it's the furthest away, so it does move towards the moon, but not as much as this or this, so it makes it seem like the water got spread out like that. So that's the reason why you have two high tides. Now that was the simple explanation for it, and of course everything is always more complicated. So if you look at that picture that shows all of the continents of the Earth, and it's got the lines in the oceans, what's really going on is that because the Earth is rotating, these water bulges, they can't keep up with the Earth because they're rubbing up against the bottom of the ocean floor and they're bumping into the continents. So what really happens is that there are these mounds of water that are out in the middle of the ocean. And so in that picture there, those are those dots where those lines are coming together. And what's happening then is you have a mound of water in the middle of the ocean that is revolving because the Earth is revolving. And as that mound of water revolves into a continent, that's when you're going to see your high tides. So it's kind of complicated, but if you would like to take a oceanography course, or just go to the internet and do a Google type in what causes the tides, you might find some explanations for this. Okay, so we're going to take a break now, and when we come back, we're going to find that it's not just the water that is being pulled towards the moon.